Hello students, welcome back to the science class. In our last class, we have discussed some concepts of gravitation. In this class, we will revise the chapter. Previously, you have already learnt about the motion of objects and force as the cause of motion, isn't it? Because of force, object moves or a moving object stops. We have also learned that force changes the direction and the speed of any moving object. We always observe that an object dropped from a height falls towards the earth. We know that all the planets go around the sun. The moon goes around the earth. In all these cases, how they are moving around, how they are not changing their place. Why is it so? They change their place in accordance with another stationary object. For example, earth changes its position but sun is stationary. Again, moon also revolves around the earth. How is it so? What makes them move around without any disturbance? So there must be some kind of force which is keeping them in a particular direction, or we can say a particular orbit, isn't it? This force is called the gravitational force. In this chapter, learn about the concepts of gravitational force. Okay? We have also learned the universal law of gravitation. Discuss the motion of objects under the influence of gravitational force on the earth. How the weight of a body varies from place to place. We have also learned the conditions for objects to float in liquids. So, an object when thrown upwards reaches a certain height and then falls downwards. It is said that when Newton was sitting under the tree, an apple fell on him. The fall of the apple made Newton start thinking. He thought that if the earth can attract an apple, can it not attract the moon? Is the force the same in both cases? He conjectured that the same type of force is responsible in both the cases. He argued that at each point of its orbit, the moon falls towards the earth instead of going off in a straight line. So, it must be attracted by the earth. But we do not really see the moon falling towards the earth, do we? Yes, we see the earth moving round the sun. We see the moon, it moves round the earth. It never comes towards earth or it never falls on earth. Neither earth falls on the sun. Otherwise, there would have been a destruction overall, isn't it? The motion of the moon around the earth is due to the centripetal force. The centripetal force is provided by the force of attraction of the earth. If there were no such force, the moon would pursue a uniform straight line motion. It is seen that a falling apple is attracted towards the earth. Does the apple attract the earth? If so, we do not see the earth moving towards an apple. Why? According to the third law of motion, the apple does attract the earth. But according to the second law of motion, for a given force, acceleration is inversely proportional to the mass of an object. The mass of the apple is negligible, small compared to that of the earth. So, though there is a force of attraction, because the mass of the apple is very, very low in comparison to the mass of the earth, we do not see the earth moving toward the apple. Extend the same argument for why the earth does not move toward the moon. Same thing, because moon has a very low mass in comparison to the mass of the earth. That's why, though there is a force of attraction between themselves, both apply force on each other. Moon moves round the earth, rather it moves and moves in a circular motion. Earth never goes towards the moon. In our solar system, all the planets go around the sun. By arguing the same way, we can say that there exists a force between the planets and the sun, but as the mass of the sun is very high than the planets, that's why planets move around the sun. The same force, the centrifugal force, acts between the sun and the planets. Newton concluded that not only does the earth attract an apple and the moon, but all objects in the universe attract each other. This force of attraction between objects is called the gravitational force. Every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. The force is along the line joining the centers of two objects. We know that there exists a force of attraction between any two objects. Compute the value of this force between you and your friend sitting close by. Conclude how you do not experience this force. The law is universal in the sense that it is applicable to all bodies, whether the bodies are big or small, whether they are celestial or terrestrial. We have also learned the importance of the universal law of gravitation. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. Those are the force that binds us to the earth, the motion of the moon around the earth, the motion of planets around the sun, and the tides due to the moon and the sun. Students, you can understand the meaning of free fall by performing the activity that is given in your book. What you can do? You can take a stone, throw it upwards, it reaches a certain height and then it starts falling down. Okay, it reaches up to a certain height. After that, without any delay, it tries to come down to the earth's surface freely. So this is called a free fall. We have learned that the earth attracts objects towards it. This is due to the gravitational force. Whenever objects fall towards the earth under this force alone, we say that the objects are in free fall. So is there any change in the velocity of falling objects? While falling, there is no change in the direction of motion, but due to the earth's attraction, there will be a change in the magnitude of the velocity. Any change in velocity involves acceleration. Whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to the earth's gravitational force. Therefore, this acceleration is called the acceleration due to the gravitational force of the earth or acceleration due to gravity. It is denoted by g, and the unit of g is the same as that of acceleration, that is ms to the power minus 2. We know from the second law of motion that force is the product of mass and acceleration. The earth is not a perfect sphere. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. For most calculations, we can take g to be more or less constant on or near the earth. You have learned that weight is the force acting vertically downwards. Here the force is acting perpendicularly to the surface of the sand. The force acting on an object perpendicular to the surface is called thrust. Okay? When you stand on loose sand, the force, that is the weight of your body, is acting on the area equal to the area of your feet. When you lie down, the same force acts on an area equal to the contact area of your whole body, which is larger than the area of your feet. Thus, the effects of forces of the same magnitude on different areas are different. In these cases, thrust is the same but effects are different. Therefore, the effect of thrust depends on the area on which it acts. Students, the effect of thrust on sand is larger while standing than while lying. The thrust on unit area is called pressure. Thus, pressure is thrust divided by area or thrust per unit area. Substituting the SI unit of thrust and area, we get the SI unit of pressure as Newton per meter square. In honor of scientist Blaise Pascal, the SI unit of pressure is called Pascal and denoted by PA. Thus, the same force acting on a smaller area exerts a larger pressure and a smaller pressure on a larger area. This is the reason why a nail has a pointed tip, knives have sharp edges, and buildings have wide foundations. All liquids and gases are fluids. A solid exerts pressure on a surface due to its weight. Similarly, fluids have weight and they also exert pressure. Similarly, fluids have weight and they also exert pressure on the base and walls of the container in which they are enclosed. Pressure exerted in any confined mass of fluid is transmitted undiminished in all directions. What is weight? Weight is the gravitational pull. So, when the object is tied to the hook of the spring balance, the gravitational force pulls it downwards, thereby changing the reading of the spring balance. We know that the elongation produced in the string or the spring balance is due to the weight of the stone. That means, when we put an object on the spring balance, the elongation or the reading on the spring balance that is shown is because of the weight of the stone or the object. Extension decreases once the stone is lowered in water. It means that some force acts on the stone in upward direction. As a result, the net force on the string decreases and hence the elongation also decreases. As discussed earlier, this upward force exerted by water is known as the force of buoyancy. Okay? Students, what is the magnitude of the buoyant force expressed by a body? Is it the same in all fluids for a given body? Do all bodies in a given fluid experience the same buoyant force? The answers to all these questions is contained in Archimedes' principle, stated as follows. When a body is immersed fully or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Now, can you explain why a further decrease in the elongation of the string was not observed in activity 10.7 as the stone was fully immersed in water? Archimedes' principle has many applications. It is used in designing ships and submarines. Lactometers, which are used to determine the purity of a sample of milk, and hydrometers used for determining density of liquids are based on Archimedes' principle. Students, with this we have come to the closure of today's science class. We have discussed about gravitational force, understand the concepts in a better way. You all should revise the chapter and go through all the concepts, because the more you revise, the better you understand. Okay students, so keep practicing, keep revising and be safe and keep smiling. Thank you.